So I think this is where we left off yesterday. So if you notice, I changed the directions a little bit. I want to actually solve the triangle. So find all three angles, all three sides. So angle C is 90 degrees. Angle A is 30 degrees, because that's what I named it as. And what did Chris say B was from yesterday? What do the angles inside a triangle have to add up to? 180. So what's 180 minus 90 minus 30? 60. So angle B is 60 degrees. Okay, how big is side A, do we know? No. Do I know side B? No. Do I know side C? Okay. So how am I going to find side A? So I'm going to have to use my SOHCAHTOA, right? So what's the one angle that I know for sure? Angle A, right? So from angle A, what's the relationship between angle A and side A? Is that the opposite, adjacent, or hypotenuse? Opposite. And then what's the other side that they gave me? The hypotenuse. So which trig function relates opposite and hypotenuse? Sine. So that means that the sine of big A is going to be equal to little a over the hypotenuse. Is everybody okay with that? Yeah? And how big is big A? 30 degrees. And how big is little a? We don't know. And how big is H? 8. So little a is equal to 8 times the sine of 30 degrees. Right, which from yesterday, it means that A is how big? That's 4. So A is equal to 4. Everybody all right with that? B is going to be the 6.928. All right, so moving on. So now I need to find B, right? So again, what's the relationship between the angle I know and the B? Opposite, adjacent, or hypotenuse? Adjacent, and what's the one side I know? Hypotenuse. So which trig function relates adjacent and hypotenuse? Cosine. So that means that the cosine of my angle, which is 30 degrees, is going to be equal to little b over 8, which means b is equal to 8 times the cosine of 30 degrees, which this time we should get 6.928. 6.928. And now I have all three angles and all three sides, so I have solved my triangle. Okay, so remember, that's what that term means. Whenever they ask you to solve the triangle, find all three sides, all three angles. Everybody okay? Now, if you notice, I just threw A and B up there wherever, right? If you were to put B down here at the 30 and A up here, that's fine. It's just that these two columns would switch. Or sorry, two rows would flip-flop. Okay? So what I'm going to do is I'm make sure that your stuff matches up to what it should be, not to what I have. So don't worry about what order you're going in. All right? If I don't tell you how to label the triangle, just label it however, but just be aware that we always put the C at the 90. Okay? Everybody okay with that? Yeah? No? Maybe? Alright. That's, I'll pick this up tomorrow. And that one. But I do want to give you the homework assignment. Most of this is pretty straightforward, using SOHCAHTOA, solving a triangle. Okay? So tomorrow we'll do the last two problems, and then you can ask questions.
A parasailer is attached with 300 feet of rope to the back of a boat. So first of all, do you guys know what parasailing is? Okay, so you're attached to a boat, so instead of skiing, you've got a parachute with a harness, and you're flying, right? So I need a boat. So first of all, I need water. Water! I need a boat. Here's steering wheel. You got the dude. Hey, what's up, man? And then you got the rope, and you got the dude who's really crazy, like, woo, spring break, 98, yeah. All right. I don't do that. And then there's the parachute. Okay? Everybody all right? Yes, no? We're at 90 degrees above the water, right? So that's your altitude. All right. So the parasailer is attached with how much rope? Okay, so the hypotenuse here is going to be 300 feet. To the back of the boat. The angle of elevation between the boat and the parasailer. So elevation means you're looking which way, up or down? Up. So from the point of view of the boat. Okay, so this is actually going to be your 90. The angle of elevation here is 48 degrees, so that goes right there. Yeah, so like we're going to assume that the boat is at the level of the water, right? Because if a boat's in motion, its tail drops, right? So the anchor point is really close to the water. Everybody okay with that? Yeah? All right. So the angle of elevation is 48 degrees. So there's angles of elevation, which is where you're looking up, and then angles of depression, which is where you're looking down, right? So from the boat's point of view, it's 48 degrees between horizontal and our parasailer. How far above the water is the parasailer? So which piece up here is going to be the distance above the water? Is that the adjacent piece or the opposite piece? The opposite. So I'm going to call that my X because that's what I'm trying to find, right? Okay. So now what you have to do is just use your right triangle trig, right? So because it's an altitude, I do have a 90 degree in here, okay? So from the angle that we know, right, from our angle, what's the relationship between the angle and the piece we're trying to find? Opposite, adjacent, or hypotenuse? Opposite, and what's the other piece they gave me? The hypotenuse. So which trig function relates to opposite and hypotenuse? Sine. So that means that the sine of our angle has to be equal to the side opposite over the hypotenuse. So how do we get x by itself? Multiply by 300. For Sparta! Okay. Sorry, I had to get that out. So what's 300 times the sine of 48 degrees? Yeah, if you haven't figured it out yet, either this entire 2 chapters is very, very, very calculator heavy. So yeah, you should probably get into the habit of busting out a calculator when you get to class. I'm down to 3 calculators from 4. So if you're counting on me to have one, that's probably going to be very dangerous. 9,434 feet, right? So about 223 feet. Everybody okay with that? Yeah? So any questions on how to take a word question and build it? So for these, if I give you a story problem, drawing the picture is going to be gigantic. All right, which I've noticed, and I've discussed this with other teachers. Is there a reason why you guys don't draw pictures when you get a word problem? Always draw. Really? Wow, okay. From now on, if you see words, draw a picture. Because it's really hard for your brain to visualize what's going on from just words, right? Which makes more sense? This or when you see the picture? As crazy as my stick figures are, does this make sense as to what we're trying to do? Okay. Without the picture, is it easy to go from the words to the math? No. So you guys wind up staring at it at the ACT going, what? I got time. See, next. That's dangerous. Okay? That's very dangerous. So if you draw the picture, at least you can guess, right? You can try to figure out what's going on. Everybody okay with that? Yeah? All right. So that's why I wanted to cover that. Next page. All right. Assume theta is an acute angle in a right triangle. Find the other 5 trig functions. Okay. Did I tell you which angle theta is sitting in? So do you think it really matters? No. So what's weird about triangles is it doesn't matter how you have your side set up unless they give you more information. Okay. So where do you want my theta? Do you want the theta up top or down low? Up top. Okay. So this is my theta. And what do they tell you about theta? Which trig function do they give you? Okay, sine of theta is 5 over 6. So what does that tell me about my triangle? Right, so what's the length of this side here? Right, because that's the opposite side, and what's the length of the hypotenuse? 6. Okay, so now can I find the missing side? Okay, Pythagorean theorem. So we're going to use x squared, which is our unknown side, plus 5 squared equals 6 squared. X squared plus 25 equals 36. So yeah, x equals square root of 11. Right, so what are they? What's the word for that? Reciprocal, right? So the reciprocal of sine is cosecant, so that's how I get the 6 over 5. Is everybody okay with that? So remember, to move from the left column to the right column or right column to the left column, they're the reciprocal functions, so we just take the reciprocal. So cosine is what over what? Okay, so adjacent over hypotenuse. So what side is adjacent to theta? Square root of 11. And what is the length of the hypotenuse? 6. Okay, what's the reciprocal of this going to be? 6 over the square root of 11. But can I have a square root of 11 in the denominator? So I'm going to rationalize this, which means I'm going to multiply by square root of 11 over square root of 11. And my final answer will be 6 square roots of 11 over 11. Is everybody okay with how I did that, or do you want me to work it out? Okay. So remember, I can multiply by 1 as often as I want, and I can write it however I want to, right? So the problem is not the 11 in the denominator, but the square root. So what I'm going to do is multiply by square root of 11 over square root of 11, because that is actually equal to what? To 1, right? I'm just being really sneaky in how I write it. So what's 6 times the square root of 11? Okay. And then what's the square root of 11 times the square root of 11? Just 11, because that's like squaring the square root, right? We're multiplying it by itself. So the square and the square root cancel. So that leaves you with just 11. And then can 6 over 11 get any smaller? No. So this is my final answer. Everybody okay with that? So remember, you cannot have a square root in the denominator. And I do want to warn you, okay, you want radical answers. You do not want this as a fraction or as a decimal. Okay, if you type this in and you get 3 point whatever, right, like 3.6, blah, 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 that's a problem because we're using fractions. Am I allowed to use a decimal within a fraction? No. But normally what we would have to do is take and actually reduce the fraction and get another decimal. The problem with that is we're rounding on a round, right? The more times you round an answer, the less accurate you get, right? We want to be as precise as possible. So we actually want to keep things in our radical form. We prefer to see square root of 11 over 6 over like 0.42 blah, blah, blah. Everybody okay with that? Yeah? So we want to try to keep things in radical form. Okay? So if you haven't been, you need to start. No, because I didn't really clarify that. Okay, so problems after today, I want you to leave in radical form. If you've already done the problem and it's in decimal form, I won't flip my stuff. But from here on out, I want radical form. Okay, so tangent. Tangent is what over what? Opposite over adjacent. So what's the opposite here? What's the adjacent? Okay, can I have 5 over square root of 11? No, I need to rationalize. So I'm going to get 5 square root of 11 over 11. 5 over 11 does not reduce. I'm done. Okay, that's what I want to see for an answer. Okay, again, it's not really hard. It's just different. Okay, because this is a correct answer. That's a precise answer. And we want precision above everything. Okay? And I know you're sitting there going, well, how come? Well, one possible application of trigonometry is like altitude for flight, right? Do you want the computer that determines how your plane that you're sitting in is flying to be accurate or to be close? Probably accurate, right? So that's what we want to be focused on, okay? The actual applications of trigonometry is, like, yeah, we'll give you the problems where it's like, what's the height of the flagpole? Who cares? But trigonometry is also used to make sure that your engine, while it's in rotation, doesn't break itself apart. Okay? It's what guarantees that your transmission actually works. Everybody all right with that? Yeah? It's also used by crime scene deconstructionists to determine who is responsible for death in a vehicle collision. Okay? This math like this determines if people go to jail for the rest of their life or not. So we want to be as accurate as we can because the true applications of trigonometry, it really, 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 really matters that you're accurate. Okay, we're talking space flight, regular flight, crime scene deconstruction. All of that stuff implies trigonometry. Okay? Yes, sir. All right. Sweet. So those are the last two. And then again, this is your homework assignment. And if you don't have a copy down, please do so.